Okay, so in this question, you have to find the area bounded by the curves x equal to log or y is equal to x log x from x equal to 0 to x equal to e.
Okay, so
tell us how we will plot this graph y is equal to x log x.
Okay, so I'm telling you the standard procedure of how you plot the graph. First thing you
so now you will be teaching us how to plot in general, how to plot graphs. Okay. So that's very important, I think.
Yeah, that is very important from the point of JEE because many questions come directly from graph. You can plot the graph and see the properties and answer the question.
And not only in this chapter, graphs are useful in entire mathematics.
Exactly. So now we come to the point like what we start with. First we test for symmetry.
Okay.
First step is we test for symmetry. We check by replacing x by minus x or y by minus y.
Okay.
If the graph remains unchanged, then correspondingly we can establish symmetry about this, in this case about y-axis, in this case about x-axis.
Okay.
So if this is satisfied, we can plot the graph in just one quadrant or probably two quadrants.
Okay.
And establish the symmetry.
So it will make our job easier.
It will make our job easier. Okay.
So after checking symmetry, we are going to check?
After checking symmetry, we are going to check for regions where positive, negative.
Regions.
Where positive, negative.
The graph is positive or negative. Okay.
Right. Suppose we can set a function fx is greater than 0. Okay, to test where it is positive. For what values of x? If x is less than 0, to test for what value of x it is negative.
Okay.
Third thing, we find the points of intersection.
With point of intersection with axes.
Okay. Axis, right? Axis. Points of intersection with
x and y axis.
Fourth step we do is we look for asymptotes.
Can you tell us what are asymptotes?
You must have studied them in your what you call it, conic sections, but still explaining it. If x tends to infinity,
okay,
and y tends to finite value, y tends to something finite, what you'll get is a graph like, okay, supposedly let's say it's going to be something like this. It's going to tend to something, I'll just clarify this, it's going to tend to something finite. Something finite, yeah. This is the value of y to which it will try to approach, but it won't be able to reach.
Okay.
So this is an asymptote. So this is an asymptotic value, okay, right? It will try to attain.
Okay. And how we are going to check this thing?
Put x tends to infinity.
Okay.
In the graph. If put x tends to infinity, and y turns out to be something finite.
Okay.
Otherwise, in normal case where y does not turn out to be finite, it will be something like this. The graph will either increase infinitely or will decrease infinitely.
Okay.
So as x tends to infinity, y can either approach something infinity, minus infinity, or can be something finite.
Okay.
Next, we can check for vertical asymptotes. This was for horizontal asymptotes. Vertical asymptotes, what we can do is, if for some particular value of x is some particular value of x, y tends to infinity, then we say that they're vertical asymptotes.
Okay. For a particular value of x, y are tending to infinity. Okay.
There are some functions which have natural vertical asymptotes. That they can be, for example, you can have tan x. Tan x has a natural vertical asymptote, or otherwise this can be found by equating denominator equal to 0. If we equate denominator equal to 0, there are two cases. Either the natural function will naturally have an asymptote, vertical asymptote, or the denominator will tend to 0. Fine.
Can you give us an example?
One more thing. One more step is left. We check for local max or minima. This is an optional step. If you want exactly precise graph, you can use this step. Otherwise, you can simply plot using this. Right.
Okay.
That's why we've taken the question. We're going to solve this question this way only. So we have x log x. X log x. The first step is we check for symmetry. We see replacing x by minus x and right. One more thing you should need to ensure is you could check for the domain as well. First step you can probably keep as domain. We usually don't keep that in account, but yeah, we can check for domain as well, where it is defined, so that you get an idea where you have to draw the graph.
Okay.
So in this case, we see that x log x in the first place, replacing x by minus x won't lead to any symmetry. We can quite clearly see that, and even replacing y by minus y doesn't lead to the same expression.
Exactly.
So it has no symmetry. Okay, and second thing, we check that x has to be greater than 0 for log x
To be defined.
right? So that makes it pretty. That makes it clear that we have to plot for x is greater than 0.
Okay.
Right. If we draw that x log x, the basic purpose of this question is not to ask you to take out the area. That obviously you can. This is for sure. You realize that x log x is quite easily integrable using by parts. It is quite easily integrable using by parts.
Exactly.
So the basic purpose is to learn how to plot the graph. Right. If we just see the portion x log x is greater than 0. The next thing we'll be testing will be x log x is greater than 0. X log x is greater than 0. We see x is greater than 0 for all the domain we have taken is x is greater than 0. So log x, we have to check for where log x is greater than 0. Log x is greater than 0. Right. So if you must be knowing some logarithmic rules. This is log base e. So as this does not lie between 0 and 1. Okay, this does not lie between 0 and 1. We can directly shift it to
log
this
x
side.
is greater than 0.
Yeah, we can straight away say e raised to the power 0, x is greater than e raised to the power 0.
That is 1.
1. So x is greater than 1, then that implies that log x base e is greater than 0. So it is positive for x is greater than 1. And suitably negative for x is less than 1. So we draw a line. This is, let it be 1 comma 0. Why am I writing 1 comma 0? It need not be y comma 0. It's basically x is equal to 1 line. So this is positive. So graph would lie here, region, and this region. Fine.
Okay.
And point of intersection we can quite clearly see is existent for x is equal to 1, where log x will become 0. So graph now.
Graph will cut the x-axis at 1 comma 0.
1 comma 0. Now two things we need to check in this case. Right. So the first thing we'll be checking for is what is the value. Right. If you just we were to this point of time, we figure out that the point of intersection would be 1, and it would be lying positive over here and negative over here.
Exactly.
So now what we can test for is what value will x log x have as it tends to 0. X log x limit x tends to 0. This will help our cause. Okay, so we try to apply this. So we get what we'll do in this case. This is just I'm not solving exactly a limit question, but you need to remember this way. Log x 1 by x, we'll divide it this way. We'll change it to this form. So we'll see this thing will tend to infinity.
Okay.
As x tends to 0, and this thing will also tend to infinity.
So we get an infinity by infinity form.
Actually, this will tend to minus infinity. So one and the same thing. Right. So now we divide.
So we will apply LH rule here.
LH rule. So we differentiate both numerator and denominator. What we get is 1 by x.
Exactly.
Minus 1 by x square. So it turns out to be minus x.
Limit x approaches 0.
Limit x approaches 0. So this thing is going to be equal to 0. So the graph, we've got another point as x tends to 0. Not exactly a point. This should be an open point.
Circle.
Open circle, because it should be open because it is not a point in the domain. Right. So now the second important thing we need to check in this case for our graph to be accurate. Actually, we can estimate the rough shape from here only. We can see it has to go down, decrease, and then go increase and reach a point where it is positive. So the graph has to be somewhat like this.
Because as x approaches infinity, the value of the function will increase infinity.
Infinity. It does
and between x equal to 0 to 1, it is negative, and after that it is positive.
So that is why we can conclude the shape. We can also find this local maximum minima.
Okay.
This local minimum, very easily. So by taking derivative, we get log x, okay, plus 1 is equal to 0 for our local minimum.
Okay.
I've differentiated the function, and that is the expression I get. We get x is equal to e raised to the power minus 1 is equal to 1 by e. So this is equal to 1 by e comma 1 by e comma, I can find out the value that too. Okay, putting it in this expression, we get minus 1 into 1 by e. It will be equal to minus 1 by e.
Minus 1 by.
So this will be the point.
Okay.
So now what we need to realize from this is, while we are finding the area under the curve, or the area enclosed by the curve and x-axis, area by curve, okay, area enclosed by curve and x-axis, enclosed by curve and x-axis, we need to take sure that the area is always positive. So even when the graph is negative, we have to take mod or the negative. So we will be integrating it this way: minus x log x 0 to 1 dx
Okay.
plus integral x log x
From 1 to e.
1 to
dx.
1 to e. That's what we had to calculate.
dx.
I'm sorry. Right. So now applying by parts, we can evaluate this. This turns out to be minus x square by 2 log x 0 to 1 minus x square by 4.
Okay.
Actually, minus x square by 4, it will turn out to be minus will turn out to be plus x square by 4 rather, if you look at it this way.
Exactly, because there will be a minus sign in the second term also.
Second term. Now the first evaluating this part, this will be again 0 to 1. I'm straight away writing the answers, right? So this part, x log x would be x square by 2 again log x square by 2 log x from 1 to e, plus, in this case it will be minus x square by 4. I'm sorry.
Okay.
In this case it will be minus x square by 4. One to e. So if you just evaluate this at x is equal to 0, okay, so this will make the job, okay, actually this will make the job tedious.
Okay.
This thing will be, as you put 1, this will be 0, but minus x square by 2 over x square by 2 log x. Okay, at x is equal to, we need to calculate, okay, this is minus x square by 2. This is limit x tends to 0. So I'm incorporating one more concept inside it. We need to calculate this. If the function tends to this thing, we need to calculate where it tends to. Like
Okay.
Plus x square by 4. So this will be 1 by 4. This thing will tend to e square by 2 into 1, because log e will be 1, and if you put 1 in log x, it will turn out to be 0. Minus e square by 4 plus 1 by 4. So
Okay.
the only step where we are left is we need to calculate limit x tends to 0 minus x
Can you
square.
explain us again that why are we calculating this limit?
Because if we put 0 in this point,
It will come out to be minus infinity.
it will come out to minus infinity, but this thing, it tends to 0 as well.
Okay.
So tending
So
to
we
0,
will find a limit in this case. Okay.
we have to find a limit,
As we are getting something that is not determinable.
not determinable, as we do for limits.
Okay.
So in this case, what we do is,
So as a general rule, if by putting some limit, if we get some indeterminable thing, we have to take limit.
yeah, exactly.
Okay.
So if we evaluate this, we evaluated minus x square by 2 log x. Let me just keep the constants outside for the time being, because constants can be multiplied later. Okay, x squared log x. So that would be equal to log x over 1 by x square. Applying LH rule, as this tends to infinity, as x tends to 0, and this thing tends to minus infinity. Okay, limit x tends to 0. This will turn out to be, applying LH rule, 1 by x minus 1 by x cube is equal to minus 2 by x cube. I'm sorry.
Yes.
So this will become,
Finally, it will be 0.
it will turn out to be 0.
Exactly.
So exactly the answer will turn out to be 1 by 2 plus e square by 4. That's the final answer.
Okay. So by this we end this question.